Hi, welcome to the Drones Garage. My name is Jacob Orchard.
I'm Guadalupe Casuso.
And we're two of the chapter leads for the Microsoft Drones Garage. And so we're here to talk about drones and the community and what we're going to do and how we're going to develop and move forward with developing drones, how do we do drones, photography, racing, all sorts of stuff. And so we have a lot of things we want to start to get going with our channel and our show and move on from there. So
perfect, yeah. And as Jacob mentioned, we have a lot of fun here in Microsoft Garage, like playing with different platforms and different kind of drone geometries and manufacturers and scenarios. So just to show you a couple of things that we've been doing, we just kick off a couple of meetups. I think it was like 2 months ago.
About 2 months ago, we started. Yeah,
we started doing things for the community of like fans, drone fans inside Microsoft. We also have other people joining from outside of the company, and we just fly, we meet up. What we do basically is we bring local people that is working in different business to talk about like trends, what they are doing, like racing stuff. But also we have people from Microsoft Research where they are talking about like how you develop your next visualization model, mapping models, how to optimize routes in order to make the use of drones more efficient, using, of course, cloud technology, Microsoft Azure, IoT, HoloLens, VR, like a huge scenario that we have here. And well, something that we envision when we think about Microsoft Garage is, oh, where are we going to start? Like we have from the builders, we have artists, people that like to
photography and then the programming, of course, which you love, right? And so different sorts of people, we have different chapter leads. You know, we're just two of the chapter leads, but other chapter leads are more involved in the racing and the FPV and all that stuff that goes with it. So we're just trying to, as a community of garage leaders, we're trying to just grow the community. And as part of that, we're trying to develop ways to give back to the people that want to come and get involved with our stuff and say, hey, here's a bunch of stuff you could do with the drones, and what is a drone, and what are they, and how, you know, there's a ton of them on the table here. We'll go through a little bit of that, but that's, we're just trying to, how do we get more people involved, and what does involved mean, right?
Yeah.
And so you're
totally, and that is something that we are realizing, like from the meetups or just get some time together or share a Slack channel, a Skype channel, chats, is like we learn a lot from each other because this is based on different skills. So as Jacob mentioned, we are going to be having like based on these things, programming sessions. So if you don't know like where to start, if you want to program drones, we expect to give you some tools and guidance so you can start with this. Or the same thing as what we're going to have for building.
Yeah, so we have this awesome kit that was donated to us by the company in Auburn called Quadristeria, which is there.
Nice.
And this is a racing drone kit that they have that we're going to film a bunch of series here in Channel 9 and show you exactly how to build this thing from the ground up and all the way to flying it. So it's going to be pretty cool. So that's in the list of things we're going to do. And so it's pretty cool, pretty awesome kit, great donation by them.
Nice.
Yeah, so.
And the reality is that we are realizing we came out always with this kind of like assembled drones or drones that really, really takes a long time to get to the point in which you can go flying, you can go break it, and all that kind of things that happens. And the reality is there is no like a guidance on that. That is based on experience, or that is what at least we are living and experiment through our meetups and what people tell us. So with that, let me start with this question.
Yes.
So you want to develop
You're the dev, I'm not a dev, and you know all sorts of stuff that I don't know, and so that's how this garage thing works.
That's
right?
a start. Yeah,
so,
that's how we start. I cannot never put something like that, but well, I will try at least.
Yes.
So in this series, what we are going to be talking in this line of series is basically what you have to know if you want to start developing for drones. And I want to keep this as simple as possible. And was something that I realized because we have different projects going on now is that if you are a software developer and you are not familiar with drone platforms, there are some specific elements that can help you starting. So we put this series where we are going to start first with an intro, like showing you what are the spectrum of platforms that you can use today for development. We're not going to start with like very low level platforms like Pizza or like something that is just to develop directly for drones that you assemble. We selected a set of brands that would let you understand the basics, and then probably you can go a little bit deeper. And what we can do is mobile applications. You can do solutions, like let's say you want to program for like the onboard, exactly, onboard devices like you have in the DJI Matrix or in 3DR Solo, or like other platforms too. And what is important is like how you get that data and take it to the cloud and think about scaling that. And then once you get that base, let's get a little bit more creative and think about like mixed reality, VR, how you do gaming. Yeah. We've been even thinking about like how to start mixing all this programming of these platforms in gaming, racing scenarios, and like honestly is unlimited.
Yeah, there's so much you could do. And they range in such great sizes, like this little tiny Whoop as it's known, and it's a mod from a fairly guy started it on the internet, took a Blade Inductrix, put a camera on it, and now people are flying them like crazy. And you compare this little tiny drone to your big Matrice, it's just, they range from crazy different sizes from all sorts of stuff as you go. So,
totally. And with that, let's take off, as I said. And the first thing is, in this part, we are going to be talking about classification. And Jacob, in fact, mentioned something very important, is you have different geometries and different sizes, and also different kinds. We will talk about fixed wings versus multicopters, quadcopters, then the drone landscape and why we selected these platforms to help you ramping up. The components, like what are the different pieces that you as a developer needs to consider, and how is to develop SDKs, emulators, the tools that you have, and like just give you some seeds so you can go and you can continue working on that. And finally, let's kind of do a little bit of demo of what you can do. I'm from Latin America, so for me, let's go to the jerga for the dummy. This is when I started, oh my God. It was like people were speaking about like UAVs, like FPV. What is FPV? Like, man. So we started like this, and this is some of the things that I recommend you to go and search is like starting. What is a UAV or a drone or a flying robot? Because that is the things that you will find when you go to any of the portal of the drone platforms, or you just go to any open source site that you have many. And then you just get familiar with all these acronyms and all this slang in the drone context or what. And I was talking to you about configuration types. So something to consider is you have the lighter at the air. We're not going to be talking about balloons here. Yeah. We jump to the other side. We will start, fixed wings. So fixed wings is basically a small kind of planes that you can basically just bring it to the air. There are like different ways, and you can make it take off, and then you can fly again. I want to enforce there is a think of geometry here. So you have to understand that it's not the same to keep in the air one quadcopter or multicopter than a fixed wing, and what are like the different considerations.
Yeah, and with fixed wings and just winged airplanes in general, you need landing space and they don't take off, and there's some, what do you do when different people go to the same field to fly, right? There's some safety stuff, like the fixed wing guys need a runway to land, the quadcopter guys, they just take off and land anywhere they want, right? And so there's some give and take, I think, even within the community. Like if you're going to go to a place to fly and there's both types of aircraft there, you want to be able to make sure everybody's communicating well together and get along, right? So it's part of making it better for everybody.
Yeah, right? That's absolutely true. And there are some good things on quadcopters that are better sometimes, like in fixed wings. Like it depends on what you want to do, what you want to develop. You need more energy power now. At these days, you have more capacity on a fixed wing than in a quadcopter, but that continuous variant. So all what we are going to be talking probably from now and in a month, we will have like a lot of changes. That's why we want to give you the foundational things. And then you have like all these classifications. Based on that, what you have to decide is, okay, so what I'm going to do, like what I'm going to be developing, what is my scenario? I'm thinking about agriculture, maybe it's like a land. It's better to use a fixed wing, but if you are thinking about mountains, the best thing is probably a quadcopter. So you have to have that considerations in mind. And this is, I was mentioning, this is changing too fast. This is just the environment, the market environment that we have today. And this is just drone manufacturers. We have like sensor companies, people that like you are going to be developing solutions. Maybe you are here at some point, who knows?
Yeah.
So with that jumps to the components. I like to keep it simple. Someone told me that if you give people 3 things, they will remember. So let's talk about 3 things. So we have, first of all, the ground base, where is the operator. Normally, I will have a controller by my hand, so the controller may or may not have a mobile phone with like an application in there. You can use tablets, depending on what you prefer. Some of the drones or the platforms make you connect that application through an USB cable to the remote, and we were talking about connections later. And others will just go through Wi-Fi. But the most important part is that the controller will be the one who will control and basically translate all the commands from your application to the drone, and then it will receive back that and it will perform the translation. Again, ground base is this, and then you can have the application that makes your life easier, as we have today in many scenarios. Well, in fact, you don't have that when you do free fly or...
No, the FPVs and the regular RC drones, this is a controller for those. They don't...
So just
they don't plug into
that is the remote for this one. Just want to say.
This is my remote for that one and a few of the other ones I have, but it doesn't have the... You don't plug it into an iPhone. You don't plug it into anything, and it doesn't have a bunch of the... There's no autopilot for it, right? Totally. So everything's controlled by the operator.
The operator, and it's very important that you have normally, when we talk about FPV, yes, you can think about FPV as the screen of your phone where you can see like the video feed and what the camera of the drone is showing, but normally you will get more in the
we should say FPV is first person view, right?
So
we mentioned that. Like, and so that what it translates to is on this little tiny whoop, the camera here, over 5.8 gigahertz transmits to a set of goggles. Which those are an example of a set of goggles, or the Fat Sharks or the other brand ones. And so as the pilot, when they're with your transmitter and you're receiving the video, you see exactly what the drone sees from the camera, and it's a very cool experience. And when you put it on people for the first time that haven't seen it, you get this reaction of like, whoa, that's crazy. And
I got that.
So you get to see it. And
I know that feeling. And in fact, we are going to be talking more about that things, but just want to share like the differences between the different platforms. So that is basically when we talk about like the ground base. Then we will talk about effectively the drone itself. And the drone can really vary, depending on what you want. Like for example, this is from DJI, an Inspire one. We have here a Matrice with different capabilities. This is more like a platform from development. We can have like from Parrot, we can have, this is a R 2.0 that is more for development, as it has an SDK, it's open source. In the same line, we have like the mini drones. And honestly, you can have like Phantom or like 3D Solo or like any other lines too. And we are not attaching this to any of the platform, because what we want is for you to identify these 3 pieces that are like common in all the drones platforms itself. And then we have the centralized services. So if I am commanding today a drone, basically I am interacting with my drone, giving directions, etc. And then my application is able to connect that services to the cloud. And in fact, just to start, the cloud is super important here, because in general, like firmware upgrades in a lot of the platforms today are performing through the mobile application. So the different manufacturers will let you know when they have a new firmware. So you just download that through the app, and of course you always can have the USB. Other thing that you can do is you can get the video from the drone, and then you can find a way in which you can stream that to the cloud, or you can just capture telemetry data. All these are the things that we're going to be showing you here. Okay?
Cool. Yeah.
And that's something important. And another point to mention here is that between the controller and the drone, is like you really, as a developer, you don't need to go that deep, but just to be aware you have different links. So you have from one side, you have the data link that would let you pass information around the different sensors that you have in the drones, and you have the video link that basically capture all the video feed of the cameras there. Awesome, and well, just to reinforce some communication stuff, that is very important,
Yeah.
please, because a lot of the accidents, and we had that.
We had
that
the
accident.
Matrice has a new leg. So,
Yes. Yeah, just lost one leg. That.
So yeah, a lot of the frequencies and they're radio controlled. So 5.8 gigahertz, 2.4 gigahertz, the different channels within those frequencies, they get interference because Wi-Fi systems are 2.4 gigahertz and 5.8 gigahertz. And so you have to be aware that certain times you're going to hit interference, and so you want to make sure you kind of check. Like we got your Matrice back from DJI after getting it replaced, and the first few test flights it didn't fly right, and we don't know why. So so we had to figure that out, right?
That is the connection part is super important. In fact, one of the things that you have to take as a practice is every time that you go outside and flying is to have like a checklist. These guys, even when these platforms are not exactly as an airplane, you need to be safe about how you fly. So make sure that the different sensors, like for example, this is a GPS. So one of the things that it does is, of course, captures the satellites. So in your app, you will have that signal itself. The same with the battery level, the same like with all other sensors. You need to make sure that your drone is calibrated, that like everything works very good there. So that is just the things that you have to consider. And well, just before jumping to show you some of the tools, when I was talking about the components, again, as a developer and understanding like the full spectrum, these are the things that you have to like be aware of in a drone. So
and we ran across this in our garage project of HoloFlight, where we had a bunch of developers come and help work on this project that we're doing and we're still developing on now as a sort of a garage project and stuff. And one of the first things people asked you was, what is a gimbal? What is this? They just didn't know. And so we were like, hey, we should probably step back and at least tell people, like, if you've never used a drone and you don't know what a drone is and you've never seen these things for the first time and you're going to develop against them, there's some stuff you should just know, basic components. So you have a list here of stuff that you would...
And this is very important. It's like this drone has like exactly the same base components that we're going to mention. We will have the same thing in all these like FPV drones, but there are some things that are not exactly like the same. For example, I was talking about GPS. You won't have a GPS in an FPV in general, at least. And of course, you will have like all that variations that you just have to be aware. But once you understand the thing, honestly, you will start to realizing automatically and learning. But it's important, like what you have to be aware of. Let's start with the gimbal. So what is the gimbal itself?
The gimbal.
Yes. So the gimbal is basically where, and here, let me go if I don't do a lot of mess. So here is, and in purpose, we don't have a camera. And so here's where the camera goes. So something very important is when you plug the camera, you will need to manage some movements because you want to say at some point from your code, hey, turn to this side and take a picture, for example. So one of the components is basically the gimbal. The majority of the drones, they have it. For example, 3DR by itself use a GoPro, and you can buy the gimbal separately, but just to be aware that that is something that you can program. Of course, the camera, where you can like perform operations like take pictures or take videos. Another important thing is the video's characteristics, that you can manage different like qualities and fits, like when you want to start, stop. That's regular things. I'm not going to enter in a lot of details. GPS, like controlling the GPS signal, the different modes, and that is something that is very interesting.
Yeah.
And in fact, I think this remote will let us explain this.
Yeah.
So we have here in the remote, but that is something that you also can review through like the APIs of the platform itself. There are like different modes where we have here P, A, and F. So what you can do is you can basically fly with a GPS or just do a manual, and you manage itself the positioning of the drone.
Yeah.
Yep.
So.
Perfect. And GPS signal is super important for, in fact, mapping and positioning. If you want to implement functionalities like go home, what is go home? Maybe you want to explain that.
Go home. So in a lot of DJIs and the other platforms, when you first fire up your remote and you get your drone on the ground and you're doing all your calibration stuff, you set a home point, and that's the point where you take off from traditionally. And so when you're flying around and you're all done, you can say, click, click, go home, or in the app, you can say go home.
Or
and
programming that.
For programming it, and the drone will fly back based on the parameters you set for the go home, which you have to be aware of. Like, so it'll go to a certain altitude and fly across that altitude over to the home point and then come down and land. So you have to be aware. Like, that's another safety thing, because you have to say, hey, if the trees around you are 50 meters tall, you may want to set the go home height to 120 meters so that you don't hit any of them on the way back home and stuff like that. So you need to be careful. We also have to be careful, as we did when we did the trees. It was slightly under a tree in the battery. In the DJI product line, when the battery gets to a certain level, it initiates a go home command automatically, so your drone gets back to you prior to it running out of battery. And so you got to be aware of like when those things happen and making sure that you understand, and that's all part of the checklist when you start understanding what's happening when you're flying. And so even though you're trying to do some cool stuff and you're trying to get photos and stuff like that, you got to pay attention to the battery, you got to pay attention to where you're at. And so when those things initiate through some automation, that's part of the defaults, you know what's going to happen. Right?
And the reality is the majority of the things are programmable. So you can set some limits of threshold. It says that the battery level, I want that when the battery level reaches like 10%, I want the drone to return home, or I can increase that. I can do it today through the app, but you can do that exactly into coding. So that is like a very important point to know. And honestly, with all the drones, when you start programming, and we're going to show you like how to be safe, because again, really security when you drive these big birds, you have to be aware that accidents may happen. So we want to enforce your responsibility on doing that. That's why you have tools like simulators and other mechanisms that will let you be safe when you test. And well, other sensors that you have the accelerometer, you have the gyroscope, and you can capture all that information through the SDK. We were talking about battery level, in fact. And battery is a world. We can say like we have like so many batteries.
They're so different. Like the battery on this little tiny thing is really super tiny.
And it lasts also like
it's only
5 minutes, 2-3 minutes.
2-3 minutes. It's not a huge battery life within that one because it's so small compared to your battery here. And
that battery lasts more or less like between 17, 20. And something that you have to consider always is that whatever you do, you have to make your solution and app aware of the battery's levels so you can, again, perform and achieve what you have to do in your application without running battery and without having like any accident itself. Another important thing is, and all the batteries are in general lithium. So that is something to keep in mind too. I put here Raspberry Pi because this is the part that I really like it. So the reason why I bought this platform is because a lot of these companies are starting to have the possibility to extend. So I'm not good at assembling these drones, but I am good maybe playing with the serial port there and putting a Raspberry Pi or putting like a manifold that is a computer where you can run or extend one of the components of this, that is the autopilot, that in fact I mentioned there as the onboard system. So you basically you have the flight controllers, you have autopilots, and you can play with external I will set power so you can enhance functionalities. And you can put like any kind of sensors.
Yeah.
A lot of scenarios today use the Raspberry Pi or the Edison or other platforms just to plug other sensors, like even thermal cameras or like temperature sensors that would let you extend that scenario.
And you go crazy, right? Because you have lots of people use Raspberry Pis today for all sorts of sensors and stuff. But just take that Raspberry Pi, now mount it on top of here with the same set of sensors, and you could do all sorts of crazy stuff, like scanning and all sorts of stuff that people are doing. And so really changing this stuff, and it's evolving really super fast. Like,
totally.
Not just only in the development side of things, but the racing side, I mean, all of
All
it, like the
all
photography side of stuff. It's the models are growing so fast, and the industry is growing fast, and it's moving quickly into different things, and everything's getting smaller and smaller and smaller as we go. So
that's a reality. And something important is when you see about these things. For example, we talk about communication, and today if you have to do agriculture, it's so complicated. Like to go from your app to download the photos or the videos and upload that to the cloud. So we are looking in models in which you have to think, where are you going to put your processing power? And sometimes, of course, you can do post-processing and send it to the cloud, but sometimes you will need some processing in the drones itself. So how can you maximize and do that? In fact, there are a lot of companies that are already doing like vision algorithms and stuff, and they're doing cool things. And one of that is, I'm going to show this. We didn't have this activated when it happened, the accident happened. But it was on. That's why it is like this.
We had our accident without this collision avoidance system installed on the.
I'm going to keep crying about that for long, but well, it's back and it will be fixed soon. So these are ultrasound sensors. So talking about safety and all these mechanisms. So what you want is to fly like in a way in which you can take your drone, go through like forests or mountains and don't be thinking about that, or warehouses, like in between boxes. So these basically let you do the object avoidance and program this and make sure like the proximity, how to react if it is, play with the GPS or the positioning, so many things. But this is part, in fact, of the components. And as you see, this platform brings some external connectors that you can adapt and you can make yourself. 3D printing is a great asset in this world. That's why we have Bob, our other lead, that he plays Bob with that things.
So, but yeah, and these things, you know, especially like the one guy we know, he has the other matrice that we use. He wants to fly it indoors.
Yeah.
Right. So indoors, the GPS doesn't work, and so having the collision avoidance system on to help him fly is a pretty important thing for him. Right?
Super
because
important.
They're gonna do their flying inside.
Yeah, totally. And you touch a very good point, because for flying indoors and outdoors is an absolutely different experience. Outdoors, you always will have probably like GPS signal. In indoors, you have to play with some things. So I like this one, that is the Parrot. For example, the Parrot has the possibility that, in fact, has this is a developer platform, but it has the ultrasound sensors or the cameras that are horizontal. So you can basically, are horizontal and vertical, so you can basically do and play with, like, be aware of the place in which you are flying, like flying indoors. We normally do a lot of testing with these platforms, or like this one that is the Sumo, or even, where is the other one?
Oh, this one.
Oh, the Airborne. I love this guy. So yeah, this is a small platform, very useful, also programmable, and very useful for like prototyping and doing like very external, So they're doing very cool things inside. So that is what you have to be aware of. Think about like the 3 components, remember, and then just double click a little bit in like what you have inside the drone, and you will be learning on the fly. So talking about that, let's go to the next one. So we decide to like teach you or giving you these guidances around like 3 platforms. And we expect that with that you will have the foundation and will be dangerous enough to go and play with others. So we select Parrot, that is this line where we have the mini drones, and honestly, none of these drones are cheap, but they have a low barrier of entry, and if you want to do serious programming there, you can have a very good experience. We have DJI that has the Matriz, the Inspire. We also have the Phantoms line. Yeah, in fact, you can start programming from the Phantom 3 mobile applications. You can do mobile applications for Inspire. You can do mobile onboard and other things with the Matriz. And we don't have it here, but we also have the 3DR solo line where you can do also very good things. I will say 3DR lean more like a development platform too, and you can add things, and I think it's very, very cool. So let me show you. Let me jump here.
Let's see your demo.
Yeah. So something that I was in fact before going to the demo itself. Let's go here. Talk a little bit about like what you need today if you want to. Here we see. Yeah, perfect. So this is the DJI site. So one of the things, and let me go to the developer portal there. So if you go and today you want to be a developer, one of the first things that you have to do, and this works like in all these platforms, you have to register yourself as a developer. I remember when I used to do like mobile applications, this is kind of the store where you have to register yourself. You don't have to pay anything at this point in any of the platforms, but you have to give them the data because after like, what are your like email and information. So after that, what it will happen is, and let me see if I go to my, so I'm going to go to my user center in this case, let me, little bit. So you have to register your apps. So let's say I'm going to create an app and I have to define if I'm going to use the mobile SDK, onboard SDK, or what SDK?
Well, why would you choose one versus the other?
That's a good question. First of all, mobile SDK. So the mobile SDK will let me communicate with any drone platform starting in the case of DJI, is starting the Phantom 3, Phantom 4, Inspire, and Matriz. And basically it's developer, if you are a iOS or Android developer, and you want to do your mobile application. And they have a lot. In fact, today, if some of you have a DJI drone, you will get the DJI Go app. So that is based on the mobile SDK. So you can extend that. You can do like mission planning. What is mission planning? Is telling the drone where to go, which endpoints, and basically what is the surface that needs to cover. So that is the mobile SDK. The other option is onboard SDK. Onboard SDK is when, as I was mentioning before, you can extend the drone itself. You can use, let's see if you can see here now. Let's see. So you have here some ports where you can just go serial. They are your T, you just plug and you basically can program your own solutions in that board. The way
so can you use the onboard SDK if you add more sensors to it that go into that 0 point, and then you extend the sensors that let the onboard system do it.
Totally.
Is that and that's in lieu of doing like attaching a Raspberry Pi and just doing those sensors from the Raspberry Pi.
Yeah, they have, in fact, they have in the site some characteristics that any board that you put in there have to accomplish, but in general, that is how it works. Okay. And at one point, DJI, and I don't know if they are still having that for selling, but they used to have a computer on board that was like the easy way of connecting with the platform, but they also have these other options as well. Okay. Yeah. And then there is one SDK that is not here, and you probably don't need to register for that, your application. That is the guidance one. Oh, so you have to do like the object avoidance programming, because you can program that. You have to download the SDK itself. So that is something that you have to be aware. Then you put like the name itself. You put the category that you want for your application, and then a small description. So what you will get when you create that, let's go to the import demo. In fact, this is the mobile SDK. And something that you get is, you probably will see here, you will get the app key. This app key is very, very important because it's what you are going to use in your application to identify that that is you and that is your app is registered. At this point, again, no charge for that, but that is how this works. And also, like 3DR with Drone Kit works exactly the same. And we will see something around that too. So that is basically what you have if you want to do an application. And another important thing is they have a GitHub repository where you have, like, from all the SDKs, you have a lot of samples that you can go download and take a look at how this is basically implemented. And you will see that all these sensors, components, etc., that we were talking about, they are going to be in the code. And once you understand, again, the physical part of this, you will be able to understand the code if you are an iOS programmer, for example. And you have, like, the information around all the SDKs. Something very important is all is something that you download is open source today. You can do pull requests, wherever, but they keep a stable version. So, because again, you cannot go and play with this all the time. So you have to be aware about the code that you put in there.
Oh, okay.
That is very, very important. And something that I wanted to show is, so we're in Seattle. We're entering the winter
rainy
time.
season started.
Jeez, don't tell me about that. Okay, so we were talking with him. Oh my God, we have to start doing some games. Or, well, at least we can have, like, an emulator. And I think that to learn, again, one of the cool things, jokes apart, is that you can have this emulator. In fact, I have my Inspire turned on, because something that I'm going to do is just with the controller, I can download this emulator and it will download the drivers. It works very good in Windows, and you also can make it work on Mac. And basically, you just set some parameters in the emulator itself. You can configure some things. I will configure show logs, etc. We set save lag, show log window. It should pop up. Okay, I will set display emulator. And something that I will have here, I don't know why we're not seeing the clear log window. Let me see if we can have it again. Show log window. Okay, let me just, here it goes. It wasn't there. Okay, let me just reset and go back again. Because this is very important. In fact, we were talking before recording is that when you program to understand the different protocols and the commands that happens in each of the actions is very important. So let's go show log window again. That is somewhere. Okay. Perfect. That's the path. Display window. Display simulator. Here we go. So this is your simulator. Let me clear the window log. And I will set start simulator. Here we go. So first of all, you will have this window that you can see here. This is not something that I programmed or anything. This is something that you can get from DJI. So first thing is you connect your drone. It can be, again, Inspire, Phantoms, or it can be the Matrice. They have a USB cable. You just connect to the drone itself, to your computer that is running this. So I started the emulator. And here in the log thing, I'm going to be seeing, like, all the commands, protocols that they interchange, like that, the packages. And on the other side, I'm going to be logging some actions and see this. Again, Jerga or slang here, you have, like, all the things. Like, maybe you want to explain, like, what is roll, pitch, and yaw, just to test you.
Roll, pitch, and yaw. So it's the way that the copter will go. So roll is left and right to the pitch is how much forward and back it goes, and yaw is how much the copter will spin around. So and then the throttle, of course, is how much power you're giving each of the motors to go. And so those things all translate into telemetry that you want as far as the developer goes. And so this also gives you an ability to, if you don't know what the command is for your SDK, and you're looking to try to figure out, like, I don't know how to do this, but I know how to do it with the controller, or you know how to do it with the app.
You just go here.
You're just going to go here and you're going to run it, and you'll be able to see in the logs what the SDK is doing. right?
Totally. And that is very, very important because it will teach you. That is the goal of all this. So here, for example, I will have the speeds. Yeah, so I have the V3 vectors, latitude, longitude, and like the coordinates itself. So let's take off.
Right?
So you see there, I'm just controlling with the remote itself and just the connection, and I'm going to make basically the drone go up and then like do different movements itself, just rotate and then go up, go home. And something that while the drone is coming is you see all the parameters, and again, as we said, you have here all the commands that is basically performing, the different actions. And just one of the things I'm going to tell the drone, just
go home.
Go home.
Yeah.
So it will perform that, and it just throw a lot of commands here. But you will see here, just to show you something familiar, the go home. Let's see what, scroll it. The go home command that will tell you the drone to go back. So great tool. And again, this is just a sample of just this platform that is the DJI one. Again, keep in mind you can program different parts, starting with a mobile app. I think it's great, and then starting expanding more. And of course, once you get all this data and you start realizing how this works, is we're starting to doing like image processing, started to do video processing. Like after X flies, I want to know like my battery performance, or something that people in Microsoft is already working in is like, what are your best algorithms for flying? Like I want to cover these fields there. First of all, geofencing. So I want to make sure that this is secure. And also like, how do I make the drone mission path to be optimal so my battery lasts the maximums and I can get the right pictures that I want?
Yeah, and a lot of that has to do with figuring out like how fast to go, how much angle does your camera cover,
yep.
right? And that's different depending on what drone you're on.
Yeah,
so,
totally.
And how much overlapping photos do you want? If your mission is to go to a 4 mile square area and take video or aerial photography of that thing, of the whole 4 miles, then you have to plan for how wide is your camera, how much overlap. So when you stitch all that photos together at the end, you want to be efficient about your battery power. You don't want to overlap too much photos, because then you have to fly more patterns around to get the entire space. And so we had a bunch of a couple interns that were actually working on a project that was trying to figure out how to optimize that.
Yep. And we will, honestly, with all this, is once we started, and we will go over, let's go back to the presentation, go to like these different scenarios. Our idea is to be showing you like how to do, as I said, virtual reality, optimizing and exploring, and basically taking advantage of the cloud and all the technologies that you can have here. Definitely unlimited. And talking about that, when we think about like all the things that today you have to do with the drone, I really, really like to think about when we progress through these shows and videos, you feel that it doesn't matter really like what platform are you going to be using. It doesn't matter if it is one drone or if you have a scenario where you will have a network of drones that you need to manage. You will have the knowledge so you can interact with different SDKs or APIs, and you are able to manage from automatic pilot, localization services, mission planning, manage FPV video, consuming data and telemetry, security, fleet management, post-processing, and I don't know exactly what we are going to come out in like a couple of months, because this is like growing. So just going back home. Yeah. So again, the opportunity that we see on this is like on the programming side, and if you start doing the things about drone, a part of being so passionate as we are is thinking about serious apps through agriculture, inspections, like so many things that you can do today in the commercial space. Race gaming. We just like every time that we talk with one racer, it has like so many ideas about like artificial intelligence, visual tracks and dynamic tracks, lasers, things that can be taken to the next level. And of course, there are a lot of cross-management services here that you will have to consider: security, fleet management, networking, and that.